Hello, class. This will be the recorded lecture for section 10.2, and this is finding confidence intervals. Instead of two means, we're going to talk about the proportion idea, the P's. So this is the confidence intervals between two proportions. And so the good news is we don't have this crazy formula for degrees of freedom here. Because if you remember, when we talk about confidence intervals for proportions, we use z-scores instead of the t-scores. So the z-score is much more straightforward in these calculations. So a little bit tedious, but not as tedious as the last section. So let's get started here. And so again, with regard to the proportions. So here would be a good example. It says here, consider the following example. We're studying the effects of air pollution on lung function. And a random sample of 50 children living in a community with a high level of ozone pollution, and they measured their lung capacity. 14 of them had capacity that were below normal. So remember, proportion means 14 yes, and then what is no? It would be 50 minus that. So that would be 36, right? And then a second random sample of 80 children was drawn from a community with low ozone levels. And there, 12 of them had lung capacity that were below normal. So remember, there would be 68 of them that had lung capacity above normal. So here we're going to compare the proportions. We'll call that P1 and P2. How do you get that? Well, each individual with low lung capacity we'll call X1 and X2, and our sample sizes will be N1 and N2. And so it's very similar to what we did in the last section. We calculate the standard error with this kind of standard deviation using the central limit theorem, adding them together, taking the square root, and then multiplying it by the z-score to get the mole. And so basically, here's what we have. And so our point estimator is the difference between the proportions. I would recommend doing this in a decimal format, but you could do it in fractions as well. And then here are our two sample variances. And then we add those together and take the square root for our standard error. And again, all predicated on the fact of this central limit theorem. And so, like I said, the central limit theorem allows us to do a lot of things because it approximates a normal distribution. And so here is our MO, or margin of error. We take our z-score, depending on our confidence interval, 95%. If you remember, would be a z-score of 1.96. And so we'll just use that for this example. And then you multiply it by the standard error. And then you take the point estimator and add and subtract the margin of error, right, or the MO, and out comes your confidence interval. So the assumptions are the same assumptions we used back in chapter 8 when we were doing a confidence interval on a single proportion. Now we're comparing two, and you could see that it has to be here, both of them have to be independent and random. And each population is 20 times as large as the sample. And it has to be divided into two categories, typically right or wrong, yes or no, true or false, and heads or tails, right? And both samples must have at least 10 in each category. And so all that needs to be true to be able to, again, do the confidence interval the way that we're going to describe. And obviously, we're going to make these true so you could actually do these calculations. So let's walk through this example here. So this is the same one here, and we're going to use 95% confidence interval. So let me pull up the whiteboard here and get all these numbers up here. There we go. I couldn't find my mouse. So let's call So we had, for the first set, we'll call that N1, we had 50 children in the high ozone. And we had X1 where there was 14 that had low lung capacity. And then in the second group, we had an N2 of 80 students or 80 children, excuse me. And in this case, our X2 was 12 with low lung capacity. So how do we get our P's? Our P1 in this case would be X1 or N1. So if you do that, that would be 14 over 50. I don't need a calculator for that. That would be 0.028. What would be P2 in this case? That would be X2 over N2, 12 over 80. Here I do need a calculator. In this case, this would be 0.15. So what is our point estimator? So our point estimator is P1 minus P2. And if you look in the book, they put these little hats on top of it like that. So just to make sure that everything follows the book, I'll do that as well. And so when you do that calculation, that would be 0.28 minus 0.15. And so that would be 0.13. So that's 13% difference out of this sample. So it's significant, I'd say, with regard to that. So what is our 95% confidence level? Implies a z-score, and they use that alpha over 2 of 1.96. So what do we need now? Well, we need the standard error. And that would look like this. It would be P1, so that would be 0.28, and then minus 1 minus P1, all divided by N1, which is 50. And then you add P2, 1 minus P2, and you divide that by N2, which is 80. And if you get out your calculator, you would see that you would get a standard error, I'll just call it SE in this case, of 0.075, and then the book had some more, 0.005. So what is our MO? So our MO, margin of error, would be 1.96 times 0.075005. And so if you do that calculation, sorry for the pause here, but I need to get the calculator out, and be 1.14701. There's our margin of error. So I'm running out of room here. So just do a little bit, finish it right up here. Could always stop the lecture and get that, right? So what is our lower bound? Well, our lower bound would be our point estimator, which is 0.13, minus our margin of error, which is 1.4701. And you can see it's negative, minus 0.017. You say to yourself, so can we do a negative? Well, of course, it would be very difficult to have a negative proportion, right? So the confidence interval contains the lowest value, then it should be a 0. And then the upper bound would be 0.13 plus 0.14701. And if you did that, and we'll round to 3 decimals, it would be 0.277. And so when you do this calculation, it's kind of interesting that you do get these lower bounds that possibly could be negative. So when you do this calculation, you could say that you would have 0.017 and 0.277 with regards to the different bounds. And so that kind of ends the details with regards to calculations by hand. What I'm going to do in the next recorded lecture is to show you how to use the technology and build a little spreadsheet for you guys so you can plug in these numbers, and a spreadsheet will give you the lower and upper bound, margin of error, et cetera, in these calculations.